Question number 4. Two metallic plates A and B, each of area 5 into 10 to the power minus 4 meter square, are placed parallel to each other at a separation of 1 centimeter. Plate B carries a positive charge of 33.7 into 10 to the power minus 12 coulomb. A monochromatic beam of light with photons of energy 5 electron volt each starts falling on a plate A at t equal to 0, so that 10 to the power 16 photons fall on it per square meter per second. Assume that one photoelectron is emitted for every 10 to the power 6 incident photons. Also assume that all the emitted photoelectrons are collected by the plate B and the work function of plate A remains constant at the value of 2 electron volt. So determine, the first one is the number of photoelectrons emitted up to 10 seconds. The second one, the magnitude of the electric field between the plate A and B at t equal to 10 seconds. And the third part, the kinetic energy of the most energetic photoelectron emitted at t equal to 10 seconds when it reaches plate B. Neglect the time taken by the photoelectron to reach plate B, and the value of epsilon naught is 8.85 10 to the power minus 12 coulomb square per Newton meter square. So the first thing which we are saying is that the two plates A and B are facing each other something like this. So this one is plate A and this one is plate B. So area of each plate, that is cross sectional area, is equal to 5 into 10 to the power minus 4 meter square, and they are separated by a distance of 1 centimeter. Now plate B is having positive charge distributed over it. So the value of charge on B is equal to 33.7 into 10 to the power minus 12 coulomb. Now a monochromatic beam of light with a photon of energy 5 electron volt each starts falling on the plate A. So the value of this incident energy on the plate A is equal to 5 electron volt. So that 10 to the power 16 photons falling on it per square meter per second. So now we are saying that the number of photons falling on plate A. So if we calculate the number of photons falling on plate A, so we can write it as 10 to the power 16 into area, that is 5 into 10 to the power minus 4. So the number of photoelectrons emitted can be calculated easily. So the number of photoelectrons emitted in the 10-second time. So in the 10-second time, the value can be calculated easily in this way, 10 to the power 16 into 10. Now for every 10 to the power 6 photon, one photoelectron is emitted. So we are dividing by 10 to the power 6. So the value we obtain for the number of photoelectrons emitted is 5 into 10 to the power 7 photoelectrons. Now these photoelectrons will result in some charge on A. So A will also become positively charged because it is emitting the photoelectrons. So charge on A will be a positive charge, and the value of one electronic charge is 1.6 10 to the power minus 19, and multiplied by the total number of photoelectrons, that is 5 into 10 to the power 7. So we get the value of the charge on A is going to be 8 into 10 to the power minus 12 coulomb. So A is positively charged. B was already positively charged, but these photoelectrons on striking B will reduce the charge of B. So B, which was originally 13.7 into 10 to the power minus 12 coulomb charge, its value will reduce by this 8 into 10 to the power minus 12 coulomb, because this photoelectrons will strike the positive charges and nullify them. So the value we obtain is 25.7 into 10 to the power minus 12 coulomb. So now we can say that the region in between over here will have a certain value of electric field, and it is because a positive charge is originating on A and hence we can say that the value of electric field will be contributed by each surface, which is equal to sigma A by 2 epsilon naught and sigma B by 2 epsilon naught. Now since these two, both of them are positively charged and sigma B is greater in value, so we will subtract sigma A and we will add sigma B. So the value of the net electric field can be calculated as sigma B minus sigma A by 2 epsilon naught. So sigma can be written as charge upon area, and then we can write it as QB minus QA upon 2A epsilon naught. So on solving this one, we obtain it equal to 25.7 minus 8 into 10 to the power minus 12 upon 2. The area is 5 into 10 to the power minus 4 and epsilon naught is 8.85 into 10 to the power minus 12. So we obtain electric field equivalent to 2000 Newton per Coulomb. So this is the value of electric field that is filling the region in between the plates. Now we are coming to the third part. So the question is saying that the value of work function is 2 electron volt and the incident energy is 5 electron volt. So I can say that the kinetic energy of the emitted photoelectron, the maximum value is going to be 5 minus 2, that is 3 electron volt. So this is going to be the maximum value of the emitted photoelectron. Now these emitted photoelectrons after coming out will get accelerated due to the electric field applied. So as a result of which we can say that the maximum value or the kinetic energy of the most energetic particle so it was emitted with 3 electron volt energy and get accelerated due to 2000 Newton per Coulomb. So as a result of which it will get 20 electron volt energy more. Why? Because the separation between them is 1 centimeter. So over here I can calculate that the potential with which it is accelerated is 2000 into 1 by 100. So we obtain a value of 20 electron volt and hence the value is equal to 23 electron volt. So the kinetic energy of the most energetic particle is 23 electron volt.